Next, we move into Friends. So Friends has a decent amount of security with adding other people. These are veterans. A lot of them are very, very oriented about security and anonymity. So the way we add friends in Op6 is a little bit different than you would on a Facebook or a Twitter or any application and the like. So if you want to add a friend, one of the users has to generate a friend code. They would click on generate a friend code, and this is only active for 5 minutes. So once you decide you want to add somebody, you have to add this quickly. Then you bounce the other user. Now I'm going to create a friend code on my own account right here, just so we could have 2 users adding one another. The other user would jump into their add by code, and they would take the friend code given to them by the other user, and they would enter it. So the only way to make a connection, and since this application is around security and real-world connections, we try to limit just mass adding people, and we really try to place a stranglehold and force people to do this when they're next to each other. So they enter the friend code. This will at a later date work off of a barcode scanner. And once they enter that, which is correct, they will get a successful friend addition. So they bounce back, and that's just to send a request. Now the request has been sent. In their pending sent, they will have added Matt, which is our other user. They could cancel that if they wanted to. And on my personal device, it shows up in a similar format of accept or reject up here in the pending. So we're going to accept that. We're going to bounce back. And now Matt is one of our friends. Now let's say you and Matt had a falling out in an event, something happened, Matt wasn't really Matt, and you didn't want to be his friend anymore, you could jump in and remove him. But before we do, as time progresses and the user would add more of their information, not just what was prompted in the initial setup, this is what their profile would look like with all of the given fields. But poor Matt, we are going to remove him. He is going to come out of our friends list. And we are in the process right now of trying to implement messaging before the semester ends. That is the last goal that we had, and we are in the process of developing that at the moment. So in full, or in part, or in full, this is our application as it currently stands, and this is the progression that we made throughout the development cycles throughout this term. So we will sign out of our user, and that is our demo. So we will jump in and explain a little bit more about that, what went well, what went wrong, and what could have went better. So that was our demo. Moving into users. So first and foremost, connections for users are very, very important. Like I mentioned, this is not a social networking app. The issues veterans face, oftentimes they do not network in real life. And we want to focus on getting people out in the open. So you can't just mass add friends. You can't just sit behind a keyboard and chat all day. We really want to focus on real world connections. So the way that we did friends and the way that we placed the stranglehold on just mass adding was in response to that. Now users could join and host events, users could chat with friends, users could review resources, users have a very, very high key on privacy, which was discussed, and they have their profile information. They have access to resources, they have access to their events, and that was displayed as seen. For events, obviously RSVP lists and attending users. They are created by users. Now, eventually, the scope of this does include organizations hosting events, but for the time being, any user can create an event, and that is what we are going into beta with. Users could comment, they could report bad events, that is in the future scope of this project, and they occupy physical space. They happen at a place at a time. They're not a resource, they don't have an office. They occupy physical space like a park, like somebody's house, like a bar, and the like. And last but not least, resources. So resources represent organizations, like I said with the veterans, like the VFW and the like. They are physical locations as well, so they have their offices, and they are rated off of user comments and ratings. They are also options to be favorited by the users. So those are our 3 major parts and how they coordinate and orchestrate with one another. So that is the project as it currently stands and the way that we plan on progressing forward in time.
Yeah, so the structure of our application remained pretty much unchanged since the beginning. Thankfully, we didn't experience any issues with Mongo, which none of us had used before. That actually made it really easy going forward when we were testing between client and server to quickly add fields that we needed. So that was great. Basically, we just route everything through Firebase authentication, which is handled by Google, so we're not actually handling any user accounts. And in the future, if they want to add any kind of social login, that'll make that easy. And also, we used Node's Express middleware to make sure that users can only access the data that is accessible to them, so friends, that made it very simple. We used very well-documented technologies, so going forward, this team doesn't have much development experience, so whoever they bring on to do that
So taking a look at some of the challenges we encountered, one of the major ones was the complexity of the system. As Matt just showed you, there were a lot of different parts going together. So like connecting with Firebase, MongoDB, and the web server and application. To authenticate, we had to use authentication through Firebase on both the server and the client to meet the design needs that the sponsor was looking for. And then additionally, this made it difficult to set up the environments initially, especially since none of us had used some of this technologies. But for the most part, we were familiar with all of them, so that wasn't a major issue. And then finally, the documentation for them, which Matt already discussed. There was a lot of different documentation that is going to have to be looked at for anyone coming onto the project, so if they're not familiar with those, that should be helpful. And then another challenge we encountered was cross-platform support. So initially this was meant to be both an iOS and Android app, but we ended up developing it mainly on iOS just due to the technologies that we had available to us. And then that led to some issues with functional testing, both testing on an app called Expo where we run a simulation of it, which actually that's what the demo is used on, and then running it on just an emulator or running it on the actual device. And then some bugs were only on one or the other. But we mitigated these issues by identifying this early on. And so we knew that this was going to come up, so we had an entire release at the end that was just dedicated to finding these bugs and getting them fixed. And then finally, we had some challenges with the requirements. There was a little bit of scope creep because the sponsors came to us with a very flexible idea, and we were the first to develop code for it, so we had a lot of room to push back on things that they wanted done that we didn't think really fit well technically, or suggest other things that we think they should do. And then also shifted priorities. And initially we had gamification was on the table as a requirement, as well as organizational accounts. And then App Store deployment was something that we were planning on doing for them and as part of our final release, but after discussing it with them, we determined that we would like to get chat as finished as we could get it. So rather than having us do App Store deployment, that's up to them when they would like to do their beta release.
So going forward for the project, as we talked about earlier, there will be a beta release for this project over the summer so that Op6 can gain research by the project, see how users in the Rochester area use it, stuff like that. For other teams working on the project, areas that they can move into are things that we had on our scope initially or some new ideas, such as gamification, data analytics, just to see how long somebody has the app open, what are they most likely doing, so that you get a better idea of what's the best payoff for making a new feature to the app, what's the best payoff for adding quality of life to it. Additionally, like we talked about earlier, resource ownership accounts, so that local resources are, when this expands into nationwide resources all over the country, can become part of Op6 as well, instead of just being a placeholder. And then as well, like Tommy pointed out when we were going over the demo, we wanted to add extending user profile customizations, and that will be added going forward by another team. Do we have any questions?
So your app looks really great to me as a software engineer, but did you have any actual potential users of the app test it or like give input for your design?
Yeah.
So the initial plan for the project was they were going to move into beta testing this summer, and weekly we showed the client the application. They're not really development extensive, so they kind of applied a third perspective to that outside of just ours. And yes, it's the intention of the customer to get it in the hands of actual users this summer. So beta testing was not really for us.
Did you have to engage with any major refactoring, or were there any aspects of your technology stack that didn't fit well to your assumptions?
One thing that did occur throughout the project was a substantial amount of returning back for the cross-platform bugs. So this does effectively work on Android and iOS at the moment, but I did the majority of the client work. I'm a big iOS guy, so it was developed on iPhones. When I would go back and test specifically for Android, there were a substantial amount of bugs that we would have to go back and do specifically for Android. So in that respect, yes, there was also refactoring in a sense of the shifting requirements and the scope creep we faced, but that was more or less editing components and backtracking. Since it was a pretty young application and we kind of knew the scope of it was going to be expanding and very fluid, we designed it in a manner as such.
Other questions?
So I saw in your architecture that you had React Native and Vue. How did that all work out?
It worked out well. So React Native was just what we chose for the mobile portion of it because with the size of the team, we did not want to develop separate Swift and Java or Kotlin applications. And the person who spearheaded the dashboard had a substantial amount of Vue experience. The dashboard, this has no real plan to be a web application, and even if it does, it's not the web portion is written in Vue. We could scale the web portion in React. Vue is just the admin dashboard that the client will use. So there's not really crossover there.
All right. Did you look at any other technologies besides React Native?
We did. So Matt and myself had some pretty elaborate conversations about the options available, and pretty much what we came to is we needed to have somebody do a substantial amount of back-end work. We knew there was going to need to be a lot of process stuff that was done, and for the client side of things, it didn't really make sense to split our 4 developers and 4 people across 2 code bases when one could accomplish the same thing. Vue Native, which is another thing that is out there now, was not as extensive at the time, and I had written a substantial amount of React Native stuff in my own time, so and we all had JavaScript experience, so that's the direction we went in for that.
Let's thank the team. You know, I have a feeling that if we didn't save the profile or whatever, because we added this in the second audio for that thing, and we tied it into everything, but it doesn't look like whatever profile stuff you use has the power to play with this tomorrow.
Good evening, everybody. We're Team Writing Styles. I Our sponsor is Janine Butler from the RIT NTID Department of Global Studies, and our faculty coach is Yasmin. I'm Donald.
I'm Stephen.
I'm Adam.
I'm Eric.
And I'm Usama.
Today, we'll be talking to you guys about what we're doing, why we're doing it, and how we did it. Give you an overview of our system and some of the design decisions we made going into this project. Talk about what we were able to accomplish in terms of what we were asked to do. Go over what we learned working on this over the past 8 months, and also a demo.
One of the things that we noticed in the problem is that deaf students, deaf and hard of hearing students are able to write well with their grammar and their sentence structure, but their vocabulary choice is usually more informal than formal. And so the NTID Department of Global Studies collaborated with us in order to provide a solution for this problem. What we were working on was a web app, which we were able to develop, that provides real-time feedback for written samples that are provided to the web. And the web app is able to do that, and we were successful in that. We were able to categorize the requirements for the customers into 4 different categories. The first category was the functional requirements, which that the web app would have the ability to be able to analyze a writing sample provided to it and recognize the words that were informal words. This involved a lot of natural language processing, which we had to learn. The second category was process. And in this, we did a lot of usability testing with students who are freshmen, were involved in a freshman English class. We'll talk about that a little bit more later. Our third category were the non-functional requirements, which focused on scalability as well as performance. Our fourth category had the most requirements. We had to work with the user interface. And we developed these requirements through 3 cycles of usability testing, and that's how we got these requirements.
All right, so this is a high-level diagram of the architecture of our application. Everything in blue is the front end, which runs in the user's browser, and everything in red is part of the back end, which runs in AWS on a web server. So this right here is the view of our application. That would be the HTML and CSS, which lays out the web page. And the front end follows an MVC architecture pattern, so that's the view. And then we have the controller, which handles all of the button clicks, and if a user hovers over something, then this will handle the logic to actually display something that should be shown. And then this piece right here is the model, which keeps track of the state of the writing sample as the user is editing it. So if they select a suggestion for one of the words that was informal and replace it with a more formal one, then this piece of the application will actually keep track of those changes. And it'll tell the controller to update the UI with those changes. And it's also responsible for making API calls to our backend to actually do the analysis of the writing sample. So this dotted line right here is the internet. It makes an API call right across that to our web server. The web app backend is responsible for routing API requests to their appropriate location. And the writing analyzer backend, right here, is the piece that actually does the analysis. It will iterate over all the words in the writing sample and find the ones which are informal, which it does by checking against the informal words list that we have right here. This isn't actually a database. It's actually just a CSV file because we have only 1,000 informal words. And keeping that into a putting that into a database would involve too much overhead for what's really going on here. It's much quicker to just read this whole file, load it into memory, and then check against all the words in the writing sample to see which ones are informal. Then once it finds all the informal and repeated words, it will go to the thesaurus, which is a database, and it will find suggestions for those words. And it checks against the word formalities database to only suggest words to users that are actually formal in the first place, because we don't want them to replace an informal word with another one. That doesn't make any sense. The other big piece here is the formality tagger. So that's how we built the word formalities database. It just has a word and then a formality score next to it between 0 and 1. 1 means it's very formal and 0 means it's informal. So the formality tagger is a machine learning model which we trained on Reddit comments, because those are really informal, and the Brown corpus, which is a huge corpus of formal writing. It's from like the 1960s, just like academic articles. And then, so the formality tagger was trained to recognize formal versus informal sentences. And then from that, we built, or we were able to derive formality scores for individual words. So words that showed up in a lot more formal sentences were given a high formality score, and words that showed up in a lot of informal sentences were given a low formality score. Yeah, so that's a pretty good overview of our architecture.
Our technical strategy to improve the workflow is what you see up here. We worked with GitHub. We commit the information to GitHub, and we created the images from that, and then Docker would pull the updates and would pull the triggers to build what we needed to build using AWS, and we used the natural language processing and Python to be able to work with AWS. And then all of that ran through into the web app.
So there were several design decisions that we had to encounter. So the first design we had to think about was the platform. Are we going to do a web app or a mobile app? And so we noticed that many students, they pick usually their computer to write essay because, a phone, that's way harder. And so we asked many students, and we asked students, would you rather, we noticed that users actually prefer the laptop. So we went ahead with satisfying the user. And that's why we developed the web app. So for the architecture, we chose the server side over the client side because it's faster to call to the database. And it's also better performance with the analyzing of the writing sample. And we also used AWS. So to analyze the writing sample, we incorporated a machine learning approach instead of the heuristic for analyzing the essays because it was a lot more available. And there was more information available in the corpus. So like long ago, there was not a lot of information on the web, so that made it a lot easier to tag words informal or formal. So for the framework, we decided to pick a light front-ended framework because it's a lot easier than a high-functioning framework. But the client side does not require the high functioning. And so when they enter the text, it would be sent to the server. So for the usability evaluation, we did 3 rounds of testing with students. There was a total of 25 new requirements, and we negotiated with our sponsor about how to reduce those requirements to 20. And we were very successful with meeting all of the 20 requirements. So these charts show the first round of the usability testings, and it shows a big improvement. And all the users were pretty much satisfied, about 60%. And the other chart shows the website expectations, and about 1/3 of them are satisfied, and the other third were neutral. So it's interesting, for our first round of usability testing, we used a mock-up, and there was quite a bit of variability with the positive comments. The second round was we actually used a prototype, and that went way up. The users liked it a lot more. And the third round it went down just a tad, but that's because we increased the baseline.
All right, now for a demonstration of what we've actually been working on this semester. So I have a couple writing samples prepared here, so I don't have to type them in. right, so when you first go to our web application, this is the first page that you're going to see. It just gives you an opportunity to type in or paste your writing sample in here for the application to actually analyze. I remember we had one issue where some students were on smaller screens and they weren't able to see this analyze button, so we went ahead and made that always visible, so that no matter how far you scroll down the page, it's always there. And you can easily see it. It's green and right at the bottom. So I'll just go ahead and paste this writing sample in here and hit analyze, and it'll send it to the web server and then do some analysis and then send it back to us. So when the writing sample is sent back to us and it's been analyzed, it will underline all the words that it found issues with. So blue means that they've been repeated, and red means that they're informal words. And you can just go ahead and hover over one of these words, and it will give you some suggestions that you could use instead of the word that you actually used. So here, attire was used 4 times in this writing sample, so it's not good, obviously. You shouldn't repeat the words nearly that much. So we can go ahead and replace it with a different word, like clothes means the same thing. And then for formal words, you can do the same thing. So if I hover over like here, you'll see that in addition to having some suggestions, I also have to choose a definition here. So it's very difficult to determine what definition of the word somebody is using in a given writing sample. So we went ahead, well, Eric went ahead and went through all the informal words that we had and figured out which definition was most likely. But there are some words that have multiple definitions and they're both of common use. For example, like. You could be trying to compare 2 different things. This is like that. Or you could be trying to express that you want something or that you enjoy something. So that's what these 2 tabs represent. So desire or similarity. If I click similarity, we'll see some suggestions for words in place of that. So I'll go back to desire and just change it to desire. That seems like a good one. The other thing to note here is that it's very difficult to come up with the exact type of word that was used in a scenario. So we put a note up here saying that you'll have to make some grammar changes after you use our application. So you could go ahead and, like, this application is mainly for just coming up with different words that you could use in certain scenarios. It's not meant to make your writing sample perfect, because there are other applications for that. There's Grammarly, where you can just paste your writing sample in just like this, but instead of getting formal suggestions, it will fix your grammar for you. The other big feature over here is that you can select words that it found issue with, and it will scroll you to the location in your writing sample where that word occurs, and it'll make it pulse, so you can figure out exactly which word is showing up over here. And we had some users saying that they were confused that this piece of the application was for actually editing, which is not the case at all. It's just to get you to jump somewhere else. So we added this just gray text to the right there saying that, no, this is a button. This is making you go somewhere. And the main other thing is this download summary. So you can download a summary of all the analysis that took place, and it will give you word by word that it found the issues with, and it will give you alternate definitions for those words, just like what you see here, only in a plain text format. Yeah, you can also go to the back button, start over, and enter a different writing sample in. And so this is an example of a writing sample that has a lot of issues with it, but if we went over here and used this writing sample, which is just from the Wikipedia page about toads, the very first thing that comes up. If we paste that in, you'll see that there are no issues with it. So if you actually paste in a sample that is formal, then it's not going to find any issues. I mean, there may be some words that are informal in your writing sample that are okay in that scenario, but that's a decision that you have to make for yourself. All right.
Overall, we've satisfied 39 out of 42 requirements, and it may sound like that's not a good number. However, all of the high priority requirements we did satisfy. At the beginning of the year, we knew we weren't going to be able to satisfy all of the requirements, and so we negotiated with our sponsor, and we figured out which were the most high priority, and we were able to satisfy all of those, most of the middle priority ones, and one of the low priority ones. And we're going to continue with the other priority requirements within the next cycle. The current state of the product is that we were able to work with the AWS website, the server, and we were able to give examples of the user to the users that we're satisfied with, and so our product is successful in that regard. And we are going to be able to help the Department of Liberal Studies to succeed in their goals.
So just a reflection. So talking about what went well for us. Like Eric said, right after the start of the semester last semester, we knew that none of us had any real formal experience working in linguistics at a higher level or natural language processing and machine learning. And even in the proposals, like, you know, we understand that you guys will need to take some time to familiarize yourself with this domain. So based on that kind of knowledge, we talked with our sponsor extensively about what we felt like we could do, such as things like word choice improvement and things that we felt like were a little bit out of depth, but we'll try to get to, which we'll talk about later. But that includes things like sentence restructuring or sentiment classifying. Worked really well with the budget because one of the requirements was to be able to deploy on AWS and host a plethora of things on AWS. So that was one of our initial things, was just calculating the budget and working within that budget. And another thing we felt like we did exceedingly well was our emphasis on usability testing. As mentioned, we had 3 rounds, and we always got really great feedback between each 3 rounds. There were a lot of small things, such as just improving white space between text that greatly increased user satisfaction, and just other things such as the actual appearance of what words are informal or what words are okay. And then now we're talking about what didn't go so well and kind of what we would do differently to rectify these things in the future. As mentioned, you know, we were kind of out of our depth in terms of some natural language processing related things and machine learning related things. In the future, we would do a better job of kind of pursuing whether they're PhD candidates or just some professors who might have half an hour to spare, and get their expertise on them, because yeah, we chose machine learning, but there aren't exactly a lot of models out there published for like, oh, you want to know how to restructure a clause in a sentence, or you want to know how to look at you know, tenses or first order logic. There aren't many resources. Another thing that didn't go so well was just our initial recruiting of users. We actually struggled really a lot with this. We thought that just offering on a poster, you know, free food would get people to sign up. This was not the case. What we learned was that we needed to actually show up in their class, be more aggressive, present to them, hey, we need your help. This is what we're doing. This could be helpful to you.
Now, our goals really was to make a database of word choices that would be better choices, and to provide that quality of service, and we were able to do that through this process. For the other senior project teams that are going to be taking over this project, there are various features that need to be supported. For example, working with passive voice. You can see how in this example here, the second bullet is an improvement on the first bullet because it has fewer words in it. The second feature that should be implemented is making sure that we replace negation with an antonym, because sometimes those can be very confusing. You know, I am not happy can become sad, and it's a much more clear that way. Another benefit of replacing those confusing words is understanding the concept of time versus length. So we want to make sure that they will be able to have those tenses and those sentence structures that will be beneficial to their writing in the future. And these are the future steps for this project. Thank you.
So when you're doing the natural language processing, a considerable risk that comes up is the time that it takes to process large amounts of corpora and perform the analytics. So how did you kind of attack and mitigate that risk?
I have a pretty decent GPU on my computer, and we trained the model on like, I forget how much data, but it only took like a few hours to train the model. It really wasn't too bad. It was a pretty simple recurrent neural network.
We also performed 2 performance tests. On the writing sample, we had 500 to 1,500 words that we used. 500 to 5,000 words that we used. And we tested different approaches to analyzing the data. And this is why we decided to use the CV file and to find essays that had informal words instead of looking it up in the database. That was part of the architecture, the decision that we made.
Which AWS services did you use, and how did you use them?
We used the virtual machine of AWS. And we put all of that into Docker, which automatically downloaded it from Docker. From the public repository in Docker. That's how we used AWS. Was somebody over there?
So my question is, the tool seems great for when you're writing, you want to paste a sample of your text in, but what if you just want to upload your entire essay? Was there ever a feature request to just have a file upload option?
There was not, but you're right, that would be a nice feature for this application.
Yeah, and just part of the reason why we didn't prioritize that was just because we figured sometimes, or a lot of times when people are looking or peer editing their own essay, they look at it in chunks rather than holistically. It's easier to focus on one section of your essay to improve at a time, but definitely just uploading an essay is something that was on consideration.
Yeah.
I noticed how you mentioned Grammarly, and I even noticed that in the input field, Grammarly showed up as a little button you click. Did you consider some sort of integration with Grammarly or making it work on the output?
We did not think of that, no. But yeah, that would probably be nice. I don't know if they support plugins or anything like that, but yeah, that would be nice if we could have a plugin for Grammarly or integrate it somehow.
Let's thank the team. Who's your professor for most of your Do you want to take linear?
I already took it.
I thought linear was easier than calculus. I hated it. Series was a nightmare for me.
Yeah, I didn't feel really bad.
Yeah, me too. That presentation was I never thought I'd be calculus.
I did a lot of things, but actually wasn't too bad.
Actually,
this side.
was actually, because I took calculus. Yeah, I took a order one.
Oh, I've heard that.
But wasn't it so much? Okay. I feel like when you take it younger, it's kind of even. Well, I put a lot of time into it. That class is like really past my life. And it was like so many classes. That class, like, good stats and all that. For the next side, I was tapped out. And it's like, I actually went to
A lot of like math, you got like boxes in your head, like how to do this.
Guys, you ready to go?
Yeah.
Okay, grab the audience.
Hi everyone, we're the RIT Sustainability Dashboard Senior Project Team. Our team name is Net Zero. I'm Nicholas Baxter.
I'm Sean Lavorse.
I'm Sergio Molina.
I'm Henry Zimmerman.
Our sponsor is Enid Carnell with the Galasanos Institute of Sustainability. We're advised by Tom Reichelmeyer and supported by ITS and FMS. Just an agenda for today, going over a project synopsis, the problem we were trying to solve, scope analysis. Since this is the first iteration of our project, basically everything was on the table for this one. We determined what we should and shouldn't accomplish this semester. The milestones we determined, the benefits and trade-offs of our architecture. And then we're going to break up the slides with our demo, then go into our challenges and subsequent accomplishments, our future plans, final reflection, and then our Q&A. The picture you see on the right there is Web Control, which is a privately used dashboard through FMS, which just contains an immense amount of data, but unfortunately the public can't see it, so that caused the conception of our project. Building on that, there's currently no way or no system for the public to see the metrics related to the sustainability efforts at RIT, and the data is currently collected and stored by FMS, which must be requested by GIS researchers before being compiled for analysis. And then our solution was a visual and interactive system allowing the identification of trends in the energy consumption production of different systems around campus. Additionally, collecting, storing, and displaying the data in one location will prevent the overhead that we currently have when researchers ask for that data. So scope analysis, if you ignore the bolding, that's everything that was on the table for this project. And then the bold is what we determined along with our sponsor as acceptable criteria for this semester. So for meter types, we did electricity, both kilowatt hours and kilowatts, basically demand and usage. And then the weather, waste, and water will be subsequent iterations. Centralized data storage to prevent that overhead that we had. Student accessible website. This is basically the public view. This would be in scope, but we had to go through an approval process that we didn't make in time. That's why it's not. Consumer-friendly visualizations, just so somebody without the knowledge base of different electricity metrics or water metrics can see and look at and determine comparisons between buildings, what would be using the most, what would be not using the most. And then exporting research data and energy reduction competitions between different academic buildings, different building types, whether it be academic or residential, just to hopefully reduce our energy consumption on campus. These are some of our milestones. On the left, you'll see the date that we wanted, or we hoped to have them completed by. The middle is the task that was supposed to be completed, and then the right is when the task was actually completed. The two rows you see with a dash are items that fell out of scope as the project progressed. Our ETL development, that was the deliverable we committed to having done 2 weeks after we returned from winter break. We met that deliverable, we missed it by 1 day. Database populated with historic data. After further discussions with ITS, it was determined that an easier way to do that, rather than exporting it through the tool they used to give us the data, was to do basically a database snapshot and upload that at a further date. Database populated with current data is basically the scope of the project we did this semester. We hope to have that done by February 25th. Ended up being done with April 5th due to delays with the system we used to transfer the files from FMS to us. Our front-end initialized, Henry actually got that done pretty early, on February 1st. Just initialized, not really fleshed out at the moment. Shibboleth auth was out of scope. Creating Tableau dashboards, we needed data to do that. It was mostly a linear progression, so since our data got backed up to April 5th, we had to create those afterwards. And Sergio was very prompt with doing that. And then embedding them in the web page, change happened since we had the dashboards on April 10th, also happened on April 10th.
So in general, our architecture served to move a bunch of data from web control into our database that we would then expose to the public. So again, web control would export all of the data on a regular basis to a zip file, which is then moved onto an FMS server, which is then moved onto our server, which is regularly pulling and moving stuff into our database. From the actual database that we're using, it would then be accessible via Tableau, a visualization software, and then that would be embedded within a web browser client when that was actually set to be finished. So in general, our architecture is pretty straightforward. There's not a whole lot to it. It's just a linear, straight shot through all of the related components. It's pretty expandable if you want to add another source of data. It's not that difficult just to attach that data source as part of the ingestion pooling. And the general use of off-the-shelf software makes it pretty cost-effective and should be more reliable than anything we could write in a semester. The cons of this is that there's a disjoint ownership over all of our infrastructure, and that FMS, ITS, and our student group needs to communicate in order to get everything working and in order. It's going to make maintenance possibly more challenging than a single group would be in the long term. And then the reliance on the off-the-shelf software, it makes it a little bit difficult in the sense that the data format isn't really in a well-defined format. It's CSV stuck inside of a zip file, so parsing that isn't exactly in a well-defined format. And that at any point, any of the sponsors could drop the software involved, which would require significant rework in everything that we've done. And so we've got, in the process of creating this application, we documented as we went through. So we initially created our SDP to just define what we were going to do throughout the semester. We created a domain model and ER diagram afterwards just to more flesh out what we were actually going to perform in that. We made regular performance progress reports to ITS, just to let them know how we were moving from a, I think once a month basis. From that, we created a README which details a significant amount of the project history and exactly how to run it and integrate it into the larger system. And that we're planning on leaving a quick start guide for the group that's coming to replace us next year, which should make it easy for them to find out who they need to talk to and what exactly they're responsible for, so they can hit the ground running and get started on the project as soon as possible.
So this is the data that we started off with at the beginning of the year. We only had historical data from 1 meter, and this wasn't very useful in terms of finding out RIT's power consumption. And so then once we were able to get more data and extract more data from most of the meters on campus, we were able to visualize that data and transform it to identify new trends. And so for example, here we have the previous month's power usage from the RIT buildings in kilowatts and kilowatt per hour. And you can see here that LBJ uses the most power. And what's great about this is that we could group buildings together and make comparisons against it. So for example, here we group buildings based off of their usage. So we have academic buildings, recreational buildings, dining buildings, and residential buildings. And with these comparisons, we could identify other types of trends. So what's great about our data is that it's granular. So we're able to create reports that we can compare against other buildings in a short time period. So for example, here these are all the academic buildings, and we're able to compare the power usage of these buildings on a 1-hour interval. And so this gives users a greater ability to identify trends. So for example, from the academic buildings, we noticed a trend where between 5 a.m. to 12 p.m., there was an increase in power usage. And between 5 p.m. to 12 a.m., there's a decrease in power usage. And this was consistent across all the academic buildings. And as a user, you can make the conclusion that these trends correlate with the faculty and where the trend begins, where the trend increases when around 9 a.m. and at the beginning of the workday, and then it begins to decrease after hours, after business hours. And again, we can make these type of comparisons against any type of building. For example, this is the same comparison but with residential buildings. And similar to the academic buildings, we were able to identify positive and negative trends. In this case, there's a positive trend in power usage in residential buildings between 8 a.m. to 10 p.m., then a negative trend in power usage between 10 p.m. to 4 a.m. And again, this could resemble this student's typical workday could be responsible for this because students are typically more active at night. And so again, so here we have the we can make comparisons against different types of buildings. We can see the academic and residential buildings, and we can notice different types of trends. For example, with the academic buildings, we notice that there's on average less power being consumed on the weekends compared to the weekdays. And again, this could be because it's not a typical workday, and there's no staff and faculty inside the building. Whereas in residential buildings, you can see that the power usage is just about consistent throughout the week. And what's great about Tableau is that it allows us to create reports and visualizations and gives users and researchers greater ability to analyze their data and identify any trends or patterns. And so here are some of the challenges we faced in our project. An issue we encountered was the prioritization of receiving files and meter data that were going to be used to generate the reports. This was dependent on other departments on campus that are responsible for the data and data transfer. Another issue we had was that the initial data we received in the beginning of the semester had a different format from the final data we received halfway through the semester. So this required us to revise our work and our data extraction. We also faced the challenge of learning how to use Tableau. Tableau is the data visualization software that we just showed you. And no one in our team had experience using Tableau because it is an enterprise software. So it took us some time to learn how to integrate Tableau effectively with our data. And another issue we had was how we assigned tasks. Our tasks ended up being sequential, and because of this, in order for us to start one task had to be completed in order to start another task. And so we created a bottleneck in our productivity. And our task creation also needed some refinement as well. Initially, our initial tasks were too large to keep track of, and were not small enough to complete in a timely manner. And so that also affected our productivity. And last, because our project will be maintained by ITS after this iteration, we had to follow their guidelines and standards, and this gave us less flexibility on our technology choices.
So despite all those challenges, we still managed to get quite a bit done for this year. So we laid this foundation for the architecture for future senior project teams to come in and pick up where we are leaving off. The overhead involved in setting up the ETL process ended up taking at least 8 months. So if another team had to come in and do that work all over again, then they wouldn't get as far as they would be able to now that we've done that groundbreaking work for them. We also initialized the communication channels between the key stakeholders of the project, the 2 different teams within ITS that we worked with, as well as FMS. So now that these senior project teams will be reaching out to these people in the future, they'll know, oh, this is what we worked on last year, and they'll understand the context behind why these students are reaching out to them, and hopefully be able to hit the ground running again next year. The creation of the ETL process, since it took 8 months, it creates a really nice resource for this centralized, normalized data. so that this data isn't in the format that it exists in web control. Now other groups beyond just this senior project group and the sustainability dashboard will hopefully be able to use this data in this easy-to-use format in the future. And we also wrote onboarding scripts since we're only really working in a development environment right now. So once we want to move to a production environment, someone will need to set up the production database with the right schema, set up the web server using the correct scripts. So by setting up these scripts, it'll be easy once that process needs to happen for someone to just click a button and have it run. Future plans for the project, in order to accomplish the goals of helping create transparency within RIT sustainability efforts, would be some sort of admin panel that would allow Enid or someone else to run competitions, as well as set constants that would be used for calculations, such as if we wanted to demonstrate how much money does it cost RIT to run this building for a week. That would involve knowing how much RIT pays for electricity. So being able to control that through an admin panel is something that we need to build in eventually. We also only touched on one of the 4 or 5 metrics that we would have liked to for this dashboard. So we touched electricity, but someone still needs to do the infrastructure behind gas, water, weather, and waste. Weather should be pretty simple since that data is in web control, but we just didn't get around to getting that in our dashboard. We also had the requirement of allowing researchers to come in and export the data that they need for their research. And so doing that bulk export should be pretty simple now that the data exists, but we would need someone to set up the event for handling when that needs to happen. And also building a structure for creating competitions so that we can sort of encourage each other as a community within RIT to reduce our resource consumption and hopefully accomplish those sustainability goals that RIT has set out. So in reflection, our biggest shortcoming was probably a lack of process. At the early stages, the fuzzy front end of a project, it's hard to sort of determine what the process is going to be, and it became harder and harder for us to stick to that initial process that we had defined at the beginning. Our biggest improvement was communication. If you saw our midterm presentation, we really struggled in communication, but in the second semester, we picked it up and we're reaching out to the right people more frequently when we didn't get those initial responses. And our biggest success we consider to be our transparency with our sponsor. We hit a lot of road bumps, but we kept her in the loop whenever we did, so that she was understanding what she could expect of us reasonably, and she's been great about being patient with us through these bumps. So the final result is this foundation that future groups should be able to come in and create an amazing product to help RIT reach its sustainability goals. Any questions?
Yeah, just so I can get a better idea of like the actual scoping of what you guys accomplished here, was what you showed there your application, or was that the Tableau deck of the different design dashboards that you guys came up with?
That's the Tableau dashboard. So Tableau is a tool for taking, so we have the database it's connected to, and you can create visualizations of that data, and you can publish that dashboard as a physical thing. But we were hoping to embed it into its own website, which we don't actually have that website completely created yet. So that's why we just showed you the Tableau dashboard, not the actual physical website that it will eventually be.
Okay, thank you.
Other questions for them? Okay, let's thank the team. Yeah, the other thing we can do is
Definitely not. Now it's mixing into the master.
how do you make it work only like this? because Lee's gonna jump in, and if he's waiting at 5:40 to come in till they're ready to go.
Oh, Khalid Fishman's gonna be here?
No, he's gonna watch the stream.
Oh.
And so
We hope.
he said he was going.
He said last time, but we don't think he did. But we'll
Benefit of the doubt. I'm sorry, I don't think that's a feature. Apologies.
Oh, that's okay. I'll just look at it. No, I just okay, can we put it up to date? I don't know, because
I use this amount of time since I can count also.
Oh.
Actually, one
Yeah, I know.
so.
Are you guys ready to go?
Yep.
Hey guys, so we're just gonna get started. Well, we're Team Purple Draft, and we worked with Galler on the Cyber Advisor project. There we go. So that's our team. So we have Kayla, Drew, Luke, and myself, Johan. So just to start our agenda, we're going to talk about the problem we presented, then what Gallerat needed for us to do for them. Afterwards, we're going to talk about what we delivered in terms of like our architecture, our front-end changes, the DevOps practices that we implemented. Then we're going to show you our demo. After that, we're going to give a reflection of what we learned and the challenges we experienced, and lastly, go over questions. So the first thing, what is Cyber Advisor? So the problem we presented starts like this. So computers are so common now that everyday devices that we have are small computers with internet connections. And we have virtual assistants like Alexa and Google Home, smart refrigerators, doorbells with webcams. Devices that didn't exist or previously were safe now have cyber attack vectors. We combine that with the fact that people have varying degrees of technical knowledge, and there aren't many mainstream tools to help people understand how to secure themselves. Users are more vulnerable now than ever. When you look at reports and statistics, data breaches grow in frequency each year, and with time, this problem will only get worse. Cyber Advisor provides a comprehensive cybersecurity survey where users can select what devices they have from a list, and then answer questions about them. The survey works for all kinds of users ranging from your typical home user to enterprise business users. Security recommendations are pulled from a database and mapped to a user's selected assets and answers by a powerful set covering algorithm. CyberAdvisor worked with the end user security in mind. Survey data is never associated with any permanent identifying information, and users own the contents of their survey. Ultimately, the purpose of CyberAdvisor is to allow users of all backgrounds to gather information they need to keep themselves safe.
So I'm going to talk about the needs from our sponsor. Gallerat required us to redesign the front end. That was the main priority of this, this iteration of the project. We are a version 2 of CyberAdvisor.
So refreshing and redesigning the front end from a logical perspective, from a user experience perspective, and just style overall. We also were required to get the application to an MVP level, so what the last team left off was a little less than that. So we were able to ramp that up. Also to update the back-end server technologies, which just made everything a lot easier for development purposes and maintainability. And as far as our last two requirements for sensical results and also rebuilding the database to map it to national standards for technology is a stretch goal for ours. As far as the result of what we have, redesigning the front end definitely went well for us. We rebuilt it using React. Bringing an application to the MVP level was something that we also were able to accomplish, as well as developing an API that separated the front end and the back end services. We were also able to flesh out our database more so that we have more assets and results as far as what they're able to take for the survey for Cyber Advisor. As far as our future goals, currently we have some concern with the scalability of our product. Just a high volume of customers, we are concerned about scalability, so that's something that a future team, we would like them to look at. We also would like to go back and refactor to use a styling framework that works more cohesively with React and utilizes their features. We also want to normalize the database and change the schema to be a little more appropriate to how our sponsor has advised changing the requirement to. Also updating to map to, again, those NIST vulnerabilities, just having a more standard vulnerability aspect to this product would be more appropriate. And then also to fine-tune further sponsor requirements. And then the last goal for future would be to add a monetization strategy, as well as having like a user login, log out, which we did not implement for security reasons.
All right, I'm going to talk to you guys about the architecture that we delivered. So originally we had a .NET Framework application. That was the first team's application, and that doesn't. It's a Windows-only system. So we converted it to .NET Core, which runs on Windows, Mac, Linux, and Docker, and has much better single-page application support. React. Also, originally, it had a Razor Pages front end, which, as Kayla stated, we changed out to React. We did this for the purposes of having better design, easier design for a complex workflow, and to be able to have a lot of guarantees, right? Code coverage metrics, all that sort of stuff. It's easier to obtain on React. Finally, in order to separate out the front end and the back end, instead of generated HTML, which is what we had with Razor Pages, we built a RESTful API to allow the front end and the back end to be developed in parallel. Here's a diagram of our architecture. We rebuilt the controllers, obviously, from the original Razor Pages controllers to RESTful controllers. We added another layer to separate that out from the database for good architectural design. And we took the original team's set covering algorithm and put it into its own little package and abstracted it away so that it wasn't as fully integrated, or wasn't as highly coupled with the rest of the system. So what did we get from the previous team? Right, this is the V2. We got a set covering algorithm. It was the primary focus of the previous team, and they did a pretty good job of it. We decided it was pretty much fine to leave it unchanged. That's the thing that takes in the user's questions and answers and spits out a set of results and recommendations for them on how they can improve their cybersecurity. They had a SQL Server database running, We made some minor changes to that to not to update stuff and to work better with our RESTful API, but we didn't do too many changes there because, of course, we didn't want to make too many changes to the algorithm, and the database and the algorithm are tied together.
All right, so jumping over to the front end of things. So like we said earlier, we did convert over from generated HTML pages to a single page application. We touched on it a little bit, but one of the main reasons that we decided to do this was it allowed for more complex but better looking and easier to use UIs than we can really get with the generated HTML. The product quality is going to be improved from this because we can more easily test and check code coverage and all that with the single page application. And as we said earlier, because we decoupled the front and the back end, we actually were able to develop them both in tandem. So one wasn't reliant on the other, and they could both be, in various states of development at any given point. Last but not least, this reduces the load on our server because we're not generating the HTML for every client that sends a request, which should help mitigate some of the scalability issues we foresee in the future. And the team chose React just because that's what we had the most experience with. But jumping over to a few of the quality of life improvements that we made with the application. There's two big ones here. First off, we put together a continuous development pipeline that makes use of a Jenkins server to monitor test results, code coverage, and deployment to our SEVM. So the server handles all of this on its own and just keeps us up to date with making sure the product's still working as we expect and that it would still work in the production environment. The configuration files for this pipeline are actually stored within the application themselves. So if the future team picks this up, they can spin up their own server and be off to the races with very little changes. The second big change we made is we built a Docker script for this to easier deploy and scalability that comes with Docker for the application.
And so now we'll move on to our demo. So we decided to add like a landing page, just kind of market the product. Here you can start the survey, you can start with importing, or you can start fresh. Importing will pull data from a previous survey. Starting fresh, you were asked some general information on what kind of system you're inquiring about, what kind of user you are. And so here is where you select the assets, and each asset you will take a survey. We have some information about what, like a description of that asset in case you're unsure if that's the one that you're talking about or not. And you can select multiple assets at a time. This is where you can select the ones that are part of your overall system, and then, like I said, you will be taking the survey for that particular asset. So in this demonstration, we're just selecting a few. You can see how they're populating on the left navigation, just to keep some sort of sense of where you are. So the first asset we selected was router, and you can answer questions here about the router that you have in your home, security questions, and then there are questions about your media server, some linear navigation at the top, moving forward. And just the UI here is just very straightforward, simple. We didn't want to overwhelm the user with more information than they needed to, because the audience that we have can be anywhere from a home user to an enterprise level user with a breadth of different knowledge about the technologies that they have. So here we can just answer some questions about each of the assets, operating support questions, if your drivers are up to date, things like that, you'd be asked. And then based on whatever you answer here, We do have the option where you don't need to answer all of the questions because some of them you might not know of, or you might not have the permissions to know about each device that you're taking this for. But you're still able to query recommendations based on what vulnerabilities we've highlighted from those, the answers to the questions that you have. We also have a configurations modal that we implemented where you are able to export the data, so the recommendations that we've given you based on the survey. You can also go back and import data there too and change the configurations there. When you're done with the survey, you can exit and it will bring you back to the home page. At this time, we just have an export option. We don't have like a user login or log out system in place. And so from here, the recommendations that we have given them are based on like security level, risk level for their overarching system as indicated by the coloring. And so just to jump into our reflection here, so what went well was we were able to accomplish really cleaning up that front end. The last product was really difficult to understand and use, especially for someone who would be a home user who doesn't maybe know about their drivers on their laptop if they're updated or not. So we really tried to simplify this entire process for them by creating that front end. The migration to .NET Core went smoothly as well, as Drew was saying, and so did our API implementation. That really alleviated a lot of stress. Containerization for ease of setup. Initially, the project took us so long to even get running on our computer as per how the last team left it. And so now by using Docker and having everything just kind of set up is very easy to pass down to later teams. Also, deployments and testing went really well. We were able to implement testing into this iteration, which was not in the last. Some challenges that we did have were last minute scope changes. So as we kind of really got in like the roots of the project and developing, our sponsor was like, oh, well, what about this? What about this concept? And so it kind of threw us for a loop at the end. It made delivering a little bit more complicated because we wanted to really embody all of those requirements. And then also just tech debt from the previous team was definitely a challenge to use. It was a really good experience overall, learning from how a previous team was able to implement something and then us changing it and working from there. And then some lessons learned, I would say that our agile methodology, we used Scrumban, which was a combination of Scrum and Kanban. And at the time, it did seem to work for our team, but as we realized later on, it would have been more helpful we kind of went into like a waterfall flow of the project. Even though we didn't have our requirements completely fledged out at the beginning, we just kind of ended up working that way. So with that, I would like to thank you guys for listening to our presentation, and I'll take any questions at this time.
Yes. So I'm just wondering how challenging and what level of effort for you guys to, once you have the application, to containerize it, or did you have any experience with Docker?
So after we made the switch to .NET Core, that was one of the things that we considered. We were kind of debating, do we leave it on .NET Framework? But part of the reason that we made the switch to .NET Core was so that we could more easily run it in Docker. After that, it really wasn't that hard. What's the Docker build script? It's like, what, 15 lines?
Yeah.
Something like that?
We did run into a few issues with running the React front end within the Docker container, but that was relatively easy to solve with Googling online.
Another question? Okay.
What are some of the specific user requirements that you have?
As far as user requirements, the sponsor really wanted something that would be marketable and kind of tangible for anyone of any knowledge of technology to use. So that was really the main user requirement, and that's what drove the initial requirement of the UI refresh, was because Someone, like I said, who would be a home user wouldn't necessarily understand how to even answer some of these questions, but for the product we need to ask them. So just kind of imagining a survey that someone could take very linearly and as simple as possible was really just the one that we had.
I guess adding on to that, there's another issue we came across with this, is that you want to be detailed enough in your UI, give people enough information, but don't want to overwhelm them with too much. The initial product we have was very dense in that it shot everything at once to the users as they selected assets, and saw that we did kind of struggle because there's a point where if you don't show enough, you might be missing a lot on key things, but if you show too much, you might scare away a lot of people.
Yes, question.
Related to the UI, it looked like you were using multi-select radio buttons rather than using checkboxes. In some cases, there were more than one option selected with a round radio button style. Do you think that might be a little confusing to users?
That is a good point, that it should be different because I guess as like a design metaphor, someone may not know the difference between like a multi-select or a single select question. That is correct. That's a problem.
Any other questions for the team? All right, let's sign them.
Yeah, we're gonna change that.
I wanted to ask you, I was like, I'm not.
Hello, everyone. Hey, everyone. We are the Tioga Tigers. I'm Stephen Malmgren.
I'm March Valentine.
Daniel Santoro.
Jeff Gowitz.
Brandon Garvin.
And today we'll be talking to you about the Tioga Taekwondo Student Management System. Our sponsor is Paul Matan, and our coach is Sky Hawker. As a quick refresher, the Taekwondo Student Management System is a web application that's used inside of the studio. It's used primarily in two ways. The first of which is used by instructors with a tablet. As students come in, the instructor will be able to mark their attendance and also mark their progress within the class. So, for example, give them a new belt rank. The second mode in which the application is used is administrative. That usually involves office staff working with information inside the application. For example, downloading students' emails so they can send out notifications. As a primary goal with this application, there's still a lot to be done within that latter category. This was an existing application, and a lot of what we had to build out was on that administration side. So we wanted to be able to make the application more useful for the office needs because the information is already in the application, and we'd be able to make useful features that just scale right off of it, integrated within that application.
So looking at how some of our major features work towards these goals, so one of the main goals that our client had was reducing the amount of work that is done on paper documents or in Excel documents. We found, as we were working through some of the requirements, we found that a lot of the processes that they were currently having frustrations with were due to the information being spread out often across multiple spreadsheets or pieces of paper, and those would often get lost, resulting in loss of information and inaccurate records. So one of the goals that we had was to consolidate as much of this information as possible into the system. So you'll see that later on with our tuition tracking, our one-time events, and instructor incentive points, which are all designed to maintain more accurate records within the system. Another big goal that we had was fixing some of the usability issues that instructors previously had while they're using the system. For example, one of the issues that instructors faced while they were walking around with the tablets, as they found that it was very difficult to update belts and stripes of students as students were gaining new belts. So because they found this process pretty difficult and lengthy, it often didn't happen, resulting in, again, some of those records being inaccurate. So we really wanted to look at the way the instructors were using the current system and the way they would like to be using it, and improving the usability from that perspective. So going into the implementation of our first major piece of functionality is one-time events. So these are single non-recurring events that administrators would create primarily for promotion tests. So when a student moves up a belt level, then they would have a test where all of the students would test for that belt at the same time. So they wanted an ability to create these events and add students to those events. And you can see that these two are the examples of previous ways that they were using to track those promotion tests. You can see that that spreadsheet shows the list of students and that attended the event and the rank that they had passed, and then the bottom sheet shows an example of a test sheet that we printed out and then hung up, for example, in the studio's office that would display a list of students' names. So we wanted to take those paper and Excel spreadsheets and consolidate them into our system. So going into the demo of how this works, so we've got an events management system. So you can see all of the currently available events. Right there you can select an event and then start to add some students to it and see the students that are currently selected. As you're adding and removing students, then you see that the count is updated, so you can keep track of how many students are already in the test, which is really helpful if you want to limit your test size to being only 20 students. Say that you have limited space availability, so you really want to make sure that you're keeping track of the number of students. So we can switch between students, switch between classes, and then this is the event pop-up. So from here, then you can make a whole lot of modifications to the event. You can delete it, you can edit any of the attributes that you'd like, and you can also view the list of students and organize them by the different attributes. So one of the functionalities that was really important for the studio was the ability to mark off students as being paid or notified right on the test sheet. So when a student makes a payment for a promotion test, then the administrator will be able to log in and then mark that student as being paid right on the test sheet, which goes towards, again, that goal of maintaining accurate records and protecting the business interest by making sure that all of the information is kept up to date and accurate. And you can see that this is the print view of the test sheet. So this contains a list of all the students. So this is a page that the administrator would print off and hang up maybe in the office so that any of the instructors that are wondering what students are going to be at their promotion test will be able to look at that really quickly and easily see which students they're expecting to see and which belts they're going to be testing for. This is showing the adding a new event. So say that we want to create a new June promotion test and want to add some students to that, so you can add in all of those attributes. Again, this, you can always go back and change that later if you'd like. We'll see that as soon as we create that event, that shows up in our list, and that's ready for us to go ahead and add some students to it. So the ability to manage multiple events and switch between events and see which students are in events really helps the instructors keep track of which students are in which events, and again, make sure that the students are signed up for promotion tests when they're need to be. Yeah, that's
one of the features that was also part of the digitalization efforts was incentive points. Incentive points is a concept of a reward system for a student instructor. So if a student instructor teaches a class, they will be able to earn these points, and these points can be used for redeem in either their own tuition payments, or they can also redeem gear in the studio shop. So the key point to this was before it was tracked inside of Excel sheet, and now they'll be able to earn these just by checking in through the system, and the redemption is handled through an administration page. So here's the example of the management page. Right now we have these students. These students have these different sets of values. We can change the date range. So let's say we wanted to see what they were like yesterday. Now you can see that there had been changes in points, but we're not allowed to redeem based on previous records because that would skew how the record history is done. In this case, I'm going to redeem some points from Adam because he just purchased a helmet and he wants to use his incentive points towards that. Here in this case, I'm checking in with Aaron, and now because Aaron's checked in, when we go back to his page, his points have increased by the amount that instructing that class would earn him. Additionally, as a student, student instructor, I can go visit my page to see my individual incentive points balance. Same thing, I can look at the date range. Now, as an administrator, when I go to edit a student page, I can actually go and change their points directly. Let's say that was an error that I redeemed these points, so I'm going to undo the redemption by resetting his points to the previous value. In addition to the points, there's a logging system that's handled. So if I, as the administrator, wants to look at the total points, so this total just gives a brief summary of how many points they earned during that period selected, how many points they redeemed during that period selected, and obviously their total points currently. Also, I can print the entire log as a report, and this will give a step-by-step action of what the redeems and additions and subtractions were, where they came from, etc., for all the student instructors in that class period.
Tuition tracking was a feature that the sponsor wanted to be able to monitor the status of individual students' payments across each payment period. They wanted to be able to quickly identify the tuition status for each student and then also modify it. So jumping into the demo, this is the administration view. They're going to go to the tuition tracking page, and they're going to be given a list depending on the specific program they have selected. So here, you'll also notice that attendance is flagged because the administrator wanted to be able to quickly identify not just when a student hadn't paid, and didn't attend, but also if they had attended but didn't pay, which is a very different problem. So here, for example, we can go in, we're going to modify Ross's, he paid August, but turns out he didn't pay July yet. So then we're going to go get a similar view across the check-in page. So this is something that you might want to do on the fly while you're out on the floor, you're talking to students, maybe they hand you a check, or you want to update something based off of what they tell you. Very similar view, smaller window though, for usability, and they're going to be able to mark people the same way. In this case, we're going to give someone credit, and Ross also didn't pay for March.
We also wanted to highlight a few other miscellaneous features that were completed, and these features included things like a printable class roster, bulk import of student data, as well as various bug fixes. These changes help to streamline the user flow of the application, as well as increase the usability, portability, and integrity of the application as well. We're going to look at the printable class roster first. This feature is, the purpose of this feature is to allow instructors to quickly learn the names of each student within a given class. This is done by having a printable piece of paper that has the pictures of each instructor as well as the name, or of each student, as well as the names, so that these instructors can match the names to the faces quicker than they would normally. Now we're going to take a look at the bulk import of student data. This is done through a CSV file that you can create by entering the data within a Excel file and then downloading it as a CSV. You can then import this into the system, and this import is doing about 50 students, so it does take some time to complete, but it's much quicker than individually going and entering the personal information for each individual student. The main goal for this feature was to make it easier for another dojo to take the application and use it within their own dojo, so that they could quickly get up and running with the application, so they didn't have to go around and manually input each individual student's data, which can take much more time than it needs to.
Okay, so that brings us to a high-level system overview of the technologies used in this project. First, we have the front end, which is built in AngularJS to provide a responsive interface. We have a Django middleware, which is used to help communicate with the SQLite database as an API. And you may notice that some of these technologies are a little bit old. So one of the major design decisions that we had to make while developing this application was whether or not to rework some of the architecture in order to update it to modern technologies. And we decided to keep the existing architecture for a variety of reasons. The first of which was that because the application needs to be hosted on an intranet for security purposes, there is no security benefit. The security benefit to updating to newer technologies is reduced because there are fewer vectors of attack, because you need to be physically in the dojo to actually attack it. Another more relevant to our project, that is, another relevant to our project trade-off of redoing the architecture would have been that we would have had to explode the scope of the application, which was beyond feasible for the amount of time that we're given in the senior project time period. Of course, the biggest trade-off of deciding not to update the architecture is that the technology, since it is already currently a little bit old, it will only age more as time goes on. And so we recommend that in the future, for any future teams that might undertake this project, that the front end specifically the front end be updated and ported to a newer, more stable framework. So over the course of this project, we learned a lot of lessons about, obviously, doing projects. The biggest of one of the biggest of which was to do things early, specifically to prepare our environments early and to make sure that our requirements are clarified early. These things did provide some setbacks for us because they ended up delaying some of the feature development in our project, and so that is something that we discovered we could have improved on. We also learned to beware of scope creep, so there were some requirements that were introduced mid-project that we definitely could have done more requirements, some more change control on. Be more conservative with estimates. We were a little bit over optimistic on some of our initial estimations and had to adjust those as time went on. Lastly, to choose useful metrics. Although we did, to the best of our ability, we did try to choose metrics that were useful for our process and for our system, given the project that we were given. There could have been some additional improvements made in our metric selection process for determining useful metrics later on in the project. Questions?
So I noticed you recommend that you update, the next group update the front end. Kind of like why you say that, are you using like older version of Angular? Is that why?
So our application is currently in AngularJS. So the starting point of Angular, so it would take a lot of work to port it over to say Angular 4 in a more modern version because the structure of the Angular pages to the front end are very different. So that's the main reason why we decided not to do it.
So what are the future goals for this project?
I'd say that there was a major requirement that was initially part of the scope that we made the project and we removed from the scope once we realized it would be kind of a bigger undertaking than we initially thought, which was the integration of Google Calendar. So that was a requirement that we initially thought we would be able to do. So that would be a full integration of the event system that we were just showing, as well as the current programs, and so that would be kind of a more. After we did some research into it, then we found that it would be a pretty big undertaking, which is why we decided to remove it from the scope. Knowing that that's a pretty high on the sponsor's priority list, and we would recommend that as a good starting place for the next senior project team, as well as making that migration to a newer technology.
Another one of the things that fell out of scope during the project was the ability to notify students as they were checking in. If a student had not paid for the current month and was attempted to check in, the only way the instructor would know that it would be to go into the check-in page, go into the overview of the attendance page rather than just having the on-screen notification during that event.
Now, I've seen this team 3 times now, so it's an established product. How does that you're given your assignment, how does that already being used and being used Django and such affect your decisions? Moving forward. And a lot of people just want to change it.
I think a large part of that has to do with the fact that the instructors and the administrators at the studio have already been so used to using this. They've been using the current version for the past few years since the last senior project team deployed it. So they've made that part of the daily studio, just the way that the studio operates. So adding on the additional features that we did add on during this cycle is only kind of like a small portion of new features for them to get used to. So it's pretty easy for them to integrate them into their daily routine once they learn how to use them. But if we were to do a major rework of the user interface, then that would require a lot more adjustment and a lot more end-user documentation, and it would require a lot more time for the instructors to get up to speed using the new system.
Very interesting seeing how it has grown over the past 3 years. usability aspect of being able to carry this device, particularly, I think it was on granting adults. So I'm just wondering, what kind of challenges are there as far as, being and observing and being able to kind of capture the activity that's happening that would have otherwise benefit from field testing? I think you're able to field testing.
Specifically, there wasn't field testing with some of the new features that we put out. Something like the belt change was a feature that did exist, and then we wanted to get the updated version quicker and easier. Do you mind repeating that last part of the question?
So I'm just wondering what aspects of that field test or that being in front of the users and usually applications were missed, or things that you learned that you would otherwise not have.
Yeah, there wasn't anything specific to what we had missed. Most of the requirements were coming straight from the sponsor as far as what type of usability you wanted for the instructors out on the floor.
Additionally, some of the bugs that we had to address as part of our usability fixation was reported by instructors. For example, if the person did not have an emergency contact on import, if you were to have gone to edit their page, their student profile page, then it would crash the application. So there were certain things that were based on